Hello everyone. So in this class I am going to explain how to solve wave equation by using Fourier transform techniques. Okay. So Fourier transform techniques ಅಂದ್ರೆ ಏನು ಅದರ ಡೆಫಿನೇಷನ್ಸ್ ಹಾಗೆ ಪ್ರಾಪರ್ಟೀಸ್ನ ನಾನು ಪ್ರೀವಿಯಸ್ ಚಾಪ್ಟರ್ಲಿ ಹೇಳಿದ್ದೀನಿ. ಸೊ ಫಸ್ಟ್ ನೀವು ಪ್ರಾಪರ್ಟೀಸ್ ಮತ್ತು ಡೆಫಿನೇಷನ್ನ ನೀಟಾಗಿ ನೋಡ್ಕೊಳ್ಳಿ. ಅದಾದ ನಂತರ ಪ್ರಾಬ್ಲಮ್ಸ್ನ ಸಾಲ್ವ್ ಮಾಡೋದಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕು. ಓಕೆನಾ. ಸೊ ನಾನಿಲ್ಲಿ ಪ್ರೀವಿಯಸ್ ಚಾಪ್ಟ್ರಲ್ಲಿ ಈಗಾಗಲೇ ಹೇಳಿರೋದ್ರಿಂದ ಈಗ ಡೈರೆಕ್ಟಾಗಿ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡ್ತೀನಿ. ನಿಮಗೆ ಮರ್ತೋಗಿದ್ರೆ ನೀವು ನೋಡಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಮತ್ತೆ ಹೋಗಿ ಅಲ್ಲಿ ನೋಟ್ಸ್ ಓಪನ್ ಮಾಡಿ ನೋಡಿ ಪ್ರಾಪರ್ಟೀಸ್ ಏನಿದೆ ಅಂತ. ಅದಾದಮೇಲೆ ನೆಕ್ಸ್ಟು ಪ್ರಾಬ್ಲಮ್ಸ್ನ ನೀವು ನೋಡ್ಕೋಬೇಕು. ಓಕೆ. ನಾವು ಲುಕ್ ಹಿಯರ್. The problem is find the solution of the wave equation second order derivative of u with respect to t into c is so t which is equals to c square into second order derivative of u with respect to x. Here x lies between 0 to infinity and t greater than or equals to 0 when subjected to the initial conditions u of x comma 0 equals f of x, ut of x comma 0 equals to 0 using Fourier transformation method. Here the boundary conditions are u and ux tends to 0 as x tends to infinity. Okay, this is the boundary condition. Now let's start to find the solution. So first we consider the given equation. So this is the given equation. So now here we apply the Fourier transformation on both sides of this equation. Now look here, the left hand side will becomes 1 over square root of 2 pi minus integration from minus infinity to plus infinity exponential of I alpha x and second order derivative of u with respect to t into dx which is equals to, and right hand side will become c square over square root of 2 pi integration from minus infinity to plus infinity exponential of I alpha x into second order derivative of u with respect to x into dx. Okay. Now left hand side will becomes so del square by del t square of this one which is equals to, now look here, so now integrating this one. Okay, so c square over square root of 2 pi integration of this one will becomes exponential of I alpha x into integration of this term. So we get second derivative of u with respect to x and the limits is minus infinity and plus infinity minus integration from minus infinity to plus infinity. So integrated term, that is derivative of u with respect to x and the differentiation of this term. So we get I alpha into exponential of I alpha x into dx. From the boundary condition this value will becomes 0. Okay. Similarly remaining is so minus I alpha ಇದೆ. ಸೊ ಅದನ್ನು ಹೊರಗೆ ತಗೊಂಡ್ರೆ c square into minus I alpha over square root of 2 pi into exponential of, again we integrate this term. So we get exponential of I alpha x into integration of this term. We get u. Here the limits minus infinity to plus infinity minus integration from minus infinity to plus infinity and integrated term, that is u, and differentiation of this one. So we get I alpha into exponential of I alpha x into dx. Okay. Now by using the boundary condition, so this will becomes 0. So remaining is, here also minus alpha is there, here also minus alpha is there. So this will becomes so I alpha whole square into c square over square root of 2 pi and the remaining is integration from minus infinity to plus infinity exponential of I alpha x into u into dx. Okay. By the definition of Fourier transformation. Okay. So now look here, this term can be represented as means 1 over 2 pi 1 over square root of 2 pi into integration of this one can be represented as capital U, and this can be represented as minus alpha square c square into u. Now take this to left hand side, we get second order derivative of u with respect to t plus alpha square c square into u equals to 0. Now write the solution to this equation. We get the solution as u of alpha comma t equals c1 into cos alpha c into t plus c2 into sin c alpha into t. Okay. Now from the given problem the initial conditions is, so initial conditions are u of x comma 0 equals f of x and ut of x comma 0 is equals to 0. So now here we apply the Fourier transformation to these two conditions. So then we get, so when we apply the Fourier transformation to this condition, so we get u capital U of alpha comma 0 equals f of s. Similarly we apply the Fourier transformation to this condition, so we get capital ut of alpha comma 0 is equals to 0. Now apply these two conditions to this solution. Okay. We get, look here, C1 equals f of alpha and C2 is equals to 0. Now substitute these two values in the solution. We get the solution as u of alpha comma t equals f of alpha into cos alpha c into t. Okay. Now here we apply the inverse transformation on both sides of this equation. Then the left hand side will becomes f inverse of u of alpha comma t. So then this will becomes small u of x comma t, which is equals to right hand side is f inverse of f of alpha into cos alpha c into t. So we apply the inverse transformation to this one. We get 1 over square root of 2 pi. So integration from minus infinity to plus infinity. So exponential of minus I alpha x f of alpha into cos alpha c into t into d alpha. Now this cos alpha c into t can be represented as exponential of I alpha c into t plus exponential of minus I alpha c into t over 2 into exponential of minus I alpha x into d alpha. Now splitting this term as 1 over square root of 2 pi integration from minus infinity to plus infinity f of alpha into this one into this one. We get exponential of I alpha of c into t minus x over 2 into d alpha plus 1 over square root of 2 pi into integration from minus infinity to plus infinity f of alpha into this one into this one. So we get exponential of minus I alpha of c into t plus x over 2 into d alpha. Okay, now look here. So in these two, 1 by 2 is common. We take it outside of 1 by 2. Then the remaining is 1 over square root of 2 pi into integration of this one. So in this, we take the minus as outside. So then the remaining is I alpha into x minus c into t plus 1 over square root of 2 pi into, so this one. Okay, now observe here. By the definition, so by the definition of Fourier transformation, this can be represented as f of x minus c into t. Similarly, this term can be represented as f of x plus c into t. Okay, hence u of x comma t is equals to this one. So hence this is the required solution for the given partial differential equation. Okay, so ಅರ್ಥ ಆಗಿದೆ ಅಂತ ಅನ್ಕೊಂಡಿದ್ದೀನಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಸಾರಿ ಇದೇ ಮೆಥಡ್ ಅಲ್ಲಿ ಸೊ ಸೆಕೆಂಡ್ ಪ್ರಾಬ್ಲಮ್ ನಿಮಗೆ ನೋಟ್ಸ್ ಕೊಟ್ಟಿದ್ದೀನಿ. ಆದರೆ ನೀವು ಈ ಪ್ರಾಬ್ಲಮ್ನ ಸೊ ಮೆಥಡ್ ಅರ್ಥ ಆಗಿರುತ್ತೆ ಅಂತ ಅನ್ಕೊಂಡಿದ್ದೀನಿ. ಸೊ ಅರ್ಥ ಆಗಿರೋದ್ರಿಂದ ಈ ಪ್ರಾಬ್ಲಮ್ನ ನೀವೇ ಓನ್ ಆಗಿ ಸಾಲ್ವ್ ಮಾಡೋದಕ್ಕೆ ಟ್ರೈ ಮಾಡಬೇಕು. ಏನಿದೆ, ಫೈಂಡ್ ದ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ವೇವ್ ಈಕ್ವೇಷನ್ ವೆನ್ ಸಬ್ಜೆಕ್ಟೆಡ್ ಟು ದ boundary conditions this one and the initial condition u of x comma 0 f of x and ut of x comma 0 is equals to g of x. ಪ್ರಾಪರ್ಟೀಸ್ ನ ನೋಡ್ಕೊಳ್ಳಿ, ಪ್ರೀವಿಯಸ್ ಪ್ರಾಬ್ಲಮ್ ನ ನೋಡ್ಕೊಂಡು ಈ ಪ್ರಾಬ್ಲಮ್ ನ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಹೋಗಿ. ಓಕೆ, ಸೊ ಈಸಿ ಇದೆ. ಸೊ ನೀಟಾಗಿ ಓದ್ಕೊಳ್ಳಿ. ಮೊದಲು ಡೆಫಿನೇಷನ್ ಪ್ರಾಪರ್ಟೀಸ್ ನ ಕಲ್ತ್ಕೊಳ್ಳಿ. ಓಕೆ, ಸೊ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಎಕ್ಸ್ಪ್ಲೈನ್ ದ ಅನದರ್ ಮೆಥಡ್. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.